Welcome back to part 2 of designing your own bracing patterns. I'm Zach from Trios Guitars and Red Tree Collective, and we're going to delve a little bit more into the depths of why bracing is the way it is and how to understand it better so that you have the knowledge to design your own pattern. In the last video, we talked about the purpose of each of these braces. In this video, we're going to talk about what these braces are actually like, what kind of profiles they are, how they're shaped, and why they're like that, and how that works to accomplish the tasks that they're each supposed to accomplish. So the X brace is often fairly consistent in height. The ends are usually scooped. Heights vary widely between 14 and 18 millimeters. The height of a brace determines its stiffness much more than the width. The width of a brace is more or less for gluing surface to the top. That's how I like to think of it. So if you have too skinny of a brace, it is more prone to popping off if the guitar was to ever get bumped or something like that. So 7 millimeters, I like 7 millimeters width. It's a nice width for less weight, but also enough gluing surface that it's not gonna pop off if the guitar gets bumped or something. So usually around 7 millimeters. A 1/4 inch is fairly common, but that's quite skinny. I like to go a little wider than that. The cross section of the braces, most of my braces I do a triangular cross section because it only makes sense. The strength of this cross section is going to be the same as the strength of this cross section simply because the height is the same. The height is what will determine the strength of the brace. So if you take away the material on the sides by triangulating it, you're actually making the brace lighter, but still the same strength. Now this intersection here, traditionally it's a box joint, so one of these braces is open on the top. Now that doesn't make a whole lot of sense because the strength of this brace is now only the strength of the height at the bottom of the box joint. So if you're doing a joint like this, I definitely recommend putting a splice over top, and that solidifies that joint. The heights vary pretty widely, anywhere between 14 and 18 millimeters on these X braces. These finger braces don't matter a whole lot. I don't even use this style of bracing. I use flat patches because the structure doesn't need to be rigid in this area. So if you add a bit of flexibility while still supporting this area, I think that's a good idea. These are two very thin braces. The way I learned to do it was I actually put a patch that goes all the way around here. I think it makes more sense, but there's quite a bit of variation in that as well. Some people actually put a patch and then also put braces on the sides, taller braces. Regardless, it's smart to reinforce this area. The rosette is on the other side is supposed to prevent cracking, but it's good to have that little bit more of reinforcement because this is obviously quite a weak part in the top. It's got a giant hole in it. This top brace, it's usually quite tall. This one is on the J45 is fairly narrow, but it's smart to make it pretty wide and pretty tall, just so that it does withstand the forces of the fingerboard pushing on the top. I also have been using heavier woods for this because I like to think of this area as not contributing to the sound of the guitar. So if I brace this heavily, then think of the vibrations as inertia. So if the vibrations hit this heavy brace, then it won't travel through the brace into the top and get lost. So same idea as having heavier sides, it'll improve your sustain and projection. This top brace is just a flat patch. There's not a whole lot to do with that. The grain's going this way across the grain to the top to reinforce from cracks. Now these lower two braces, they're a little bit different because these braces are being pulled up on the top. They're actually wanting to belly up. So the profile of these braces is actually, you should be thinking of it a bit differently because the tops of the braces are actually in compression. The rest of the braces on this top and the X braces from this point upwards, the tops of the braces are all in tension. Now, the compressive strength of spruce is about half its tensile strength. So you have to keep that in mind. If you make these braces triangular, like this cross section, and really skinny at the top, it's not going to have the same strength as a brace up here that's the same cross section. So I like to leave the tops of these braces a little bit wider. So a triangular cross section, but about 2 millimeters wide at the top. There's a few different ways of doing the bridge plate. Probably maple is your most common bridge plate material. It's strong and resists wearing from the string balls on the inside. Also, the size of this bridge plate, I think this bridge plate is too small. This bridge is very narrow to begin with, so this torquing motion is not being supported on the front and the back very much at all. So this bridge, I'm sure, is going to belly up a little bit more than most bridges. But the general rule of thumb is about 1/4 inch past the back side of the bridge. Any more than that, and supposedly it actually chokes the sound of the guitar a little bit. Grain orientation is usually across the grain. Some luthiers put the grain diagonally so that you don't end up with a row of holes in one grain line on the bridge plate. So that can be done as well. When you're drawing out or planning your bracing, you need to start with a few parameters. So obviously your guitar shape, the center line, and your bridge, your sound hole, and where your fingerboard's gonna end. So I'm gonna start by doing that. So I know my neck is going to join the body at the 14th fret. So this is my fingerboard template. If you line it up at the 14th fret, you can mark where your 12th fret is. And that is theoretically the halfway point between your nut and your saddle. So I can measure from this 12th fret another 12 frets, and then add the compensation. So saddle ends up, that's where the high E is going to end up. It's going to be somewhere there. Square that up. I should have marked. Also want to mark where the 20th fret's going to be. That's going to be the last fret, which means there's going to be another centimeter past that of fingerboard, and that's where the edge of the sound hole starts as well. So I placed the sound hole according to where the end of the fingerboard goes. The further you can put the sound hole this way, the better, because then you have more vibrating area up here. So the end of my fingerboard is carved to match the shape of the sound hole, and that allows me to push that sound hole a little bit further up. When you plan out your X brace, one of the most important things is you have to catch the end of the bridge with those braces. So you don't want the brace to end up over here or over here. You need it to end up right over the bridge. Now, if you have a Martin style bridge, it's a little bit different. You've got those points stick out a little bit more. I don't particularly like these points, structurally speaking, when it's cantilevering over the X here, but it allows you to push the limit a little bit more. My bridge actually follows the angle of the X, which is on purpose. So if I go, let's say I go something like this, that would give me an angle of, let's see, about 95 degrees total if I go like that, which is nice. That's a nice angle, a little bit obtuse. So, and the bracing's about 7 millimeters wide here. And if you draw your lines past your outline, it'll actually help you later, because you can actually sit the top right over top of this drawing, and you can transfer these lines with the ruler over the top. So I'd recommend extending those lines past. Makes your job a lot easier later on. Okay, so that is about a 95-degree angle. I'll double check that. Yeah, it's like 94.5. So I'll say it's 95 degrees, which is nice. I like going a little bit obtuse. But you can see it's catching the sides of the bridge, which is good. That means the bridge, when the strings are pulling up on the bridge, it's going to pull on the X, not just the bridge plate. If your bridge ends over here, then you're going to be pulling on just the bridge plate. It could cause some pretty serious issues in the guitar. Okay, and then this upper brace, it's the big fat one here that has to support the fingerboard. I actually go, my theory here is that if you can put something heavy, it's actually better tonally, because then you have it's about a ½ inch wide. And then vibrations basically hit this heavy mass and they bounce back, or they don't get lost past this area. So a heavy brace there, and now I actually do a fully bolt-on neck. So I have a block that goes up here. This block is attached to the rim, of course, but it actually glues against the side of this heavy brace. So what you end up with is a pretty solid mass. This block is glued to this brace, and then the neck is bolted up through this block. Okay, and then I do put a patch in here, so similar to the traditional patch. This patch is fairly important, just so that you don't get a crack next to this block. So if you kind of follow the curving, it's a little easier there. This is the important spot right here, though. I carry this patch through, because if I was to end this patch against this block, then the weak spot right here is still there. So when I'm fitting the top onto the rim and this block, I actually notch out a ledge for this entire patch. It makes a lot of sense, I think, because then you're reinforcing this weak spot on either side. And the bridge plate, also an important part of the puzzle. These are the basics that I would start with. You don't have to follow it exactly, but this is where your structural stability is really needed. Otherwise, this area, you can affect the sound of your guitar quite a bit by changing the bracing in this area. So I think this is a good place to start. Again, don't go too out of the box, just because this is sort of a very important area structurally as well. So you can try a few different things, but make sure that you have bracing that bridges across this area. So whether it's a brace that goes across this way or a brace that goes down, like the Martin style bracing tone bars, either one of those is good, or even another X or another couple X's. What you don't want to do is have braces that start at your bridge plate and move down or something like that, because it'll belly up. Those braces won't stop the guitar from bellying up, because it'll just hinge at the back of the bridge plate here. Another consideration is if you are putting braces over the bridge plate, and this is becoming more and more popular, to put like a lattice down here. You can do that, just know that when you put braces over top of your bridge plate, you are basically making it impossible to replace the bridge plate in the future. So if you're doing that, be aware of that. I don't like to put braces over top of the bridge plate for that very reason, just in case. So there you have it. You can do a number of things. The braces back here, you do want to make sure they're tall enough to support that pulling up motion. So if you have a brace that goes straight across, you're talking like 13-14 millimeters tall. Or if they're at an angle like this, again 13 or 14 millimeters tall for the one closest to the bridge. And that has to be for long enough that it's supporting the top from bellying up over here too. So you want 13 to 14 millimeters tall for quite a length on this brace before it tapers down to nothing. So hopefully that is enough to give you a good footing on designing your own shapes. It is fun to experiment, but be careful. You don't want to make firewood. If you do have a bracing that you're not sure of, or if it's a little far out there and you want to run it by me, I'd be happy to take a look at it and give you some opinions or thoughts on it. There are many ways to make a great sounding guitar. This is obviously more of a traditional way of doing it, and it sort of lends itself well to that sort of sound, which I personally, I guess I can say I like a more traditional sounding guitar, just with a bit more clarity and headroom. There's all sorts of bracings out there, but this is definitely the most common one. Another good thing to do, and this is just for your own knowledge, is to actually take braces and check their deflections. So if you take braces and you carve it to the profile that you like and the height that you want, and then you suspend it from 2 points and hang a weight from it, you can get a pretty good idea of what that brace is going to take. Now, this kind of steel string guitar is a little trickier to know what kind of forces are acting. Because it's a torquing force, it's hard to know how many pounds are pulling up or down, pushing down. On another kind of guitar, let's say you have a floating bridge, a tailpiece, and a cantilevered fingerboard, then you'll know that that bridge is pushing down only. So calculating that pressure is pretty simple, and then you can actually check your brace deflection with that weight. That's a good way of checking, just to make sure that you are bracing enough or to reach a target deflection. So with my Ember series guitars, I actually tested deflections of braces on their own, and then I tested deflection after the top was braced, and basically carved the braces until I had the deflection that I wanted. So it is easier with that type of guitar because you can sort of figure out what kind of forces are acting on it. This is a little trickier, but I know that 13 to 14 millimeters for this top brace area is a good height, and then you can go a little bit shorter for the bottom ones, 12 to 13 millimeters, and that's a good general rule of thumb. So hopefully that's good to get you started on designing your own brace patterns. Let me know if you have any questions about this, or if anything's not very clear to you. I'd be happy to explain it further. Or if you have an idea for bracing and you want to run it by somebody, I'd be happy to take a look at it as well. Just send me a message or put a question in the comments below and I can try to answer them. Thanks for watching. I hope you enjoyed. If you like this video, don't forget to give it a like. Subscribe so that you can see future videos. And if you have any questions, drop them in the comments below and I'll do my best to answer them.